So if you're listening to this, we're kind of going to kill off some of worksheet number 10 before we start the new notes. So number 1, we should be good with that, just knowing if a definite integral is considered improper or not. Letter A, easy to spot because of the infinite bound. So you should put improper, infinite bound. Letter B, that gets missed actually the most. That's the most missed because you tend to just get rolling with integration and you're going to miss that. So I'm just going to warn you of that when you take your test Tuesday. Watch those bounds. So that one's actually improper because the asymptote occurs on the way from limit to limit. Letter C is improper because the asymptote's at a limit. And letter D is as normal. So that would be proper. It has no issues between the limits. Are we good with knowing whether one's improper or not? Another infinite bound, asymptote on the interval, that type of stuff. So I told you that I think this worksheet, the person was following a little different process, and they would do series, I think, after. And that's what this number 2 is trying to get people to think more in terms. There's a test you're going to learn. There's 11 of them when we get to series. You're going to have 11 tests on whether they converge or diverge. That's why I'm going to wait on it, because there's a lot of memorizing for those tests. But one of those tests is called the comparison test. It's called a direct comparison test. And it basically, the only difference between the series is that instead of an integral there, you're going to see a summation symbol. And it's going to go from n going from like 1 to infinity. But when you do the summation, you go 1 and then 2 and then 3 and then 4 and then 5. Does that make sense? You run through the counting numbers. When you do a definite integral and go from like 1 to infinity, you cover all real numbers on the way. So there's a small difference. But integrals and summations or series are really similar. And one of the things that you're going to get taught when we go to series is that if you can get something to ride above something that you know diverges. So think of that. You're above something you know diverges. What do you think it has to do? Diverge. And also similarly, if you can get something to ride below something that converges, what will it have to do? Converge. Now the other two are inconclusive. If you're below a divergent, then that's a test we won't be using when we do series. There's a whole bunch of tests. If you're like, well, I got it below a divergent, you'll be like, I'm not quite sure. And if you also get it above a convergent, you're going to be, I don't know for sure. So that's what this number 2 is gearing you towards. So let's pick it apart. 2A. They're telling you with that notation. I told you I got a foreign language credit. I think I told you guys for one of my calculus classes at Gustavus. I don't remember which one, but you can see why. Because if you were to ask anybody in this building to decipher what letter A is asking, they wouldn't know. But we should figure it out. In the first notation where it says if the definite integral from a to infinity of f of x equals k, what are they telling you? It converges. So go ahead and write convergence. So they're telling you this is math notation for this is settling at a constant. We're calling it k. So you have something that converges. Then they talk about g, but they tell you with that next inequality for 2a, if you're listening to these. Yeah, they're telling you g of x is riding below something that converges. So what conclusion can you tell me about g? It converges, yes. So you can just go ahead and write below a convergent will converge. I will not ask you these on your next test. I can tell the author of this worksheet, it's actually really smart. If I was covering series next, I would love this question because it gets you to think about it before you have to. The letter B. Also in that first definite integral, it says it's k. That means it converges. But then what do they tell you about g? Rides over. So what do we say? Yeah, we don't know. It's inconclusive. And if we're doing series, what we'd do is we'd have to use one of the other 10 tests because you're going to have 11 of them. And you have to keep track. And you're going to go, well, I know I can get this under a convergent. It converges. Then use that test. But that would be inconclusive for B. How about letter C? It's telling you that f of x diverges. By the way, it's not the function that's diverging. It's the area, right? That's what the definite integral is. That's diverging. The area is keeping and accumulating. So the function's actually converging towards the x-axis a lot of times. But the area is diverging. Anyway, what do they tell you about g with that next inequality? It's above a divergent. What does that mean? It's divergent. If that thought process is settling well with you, that's actually a little cornerstone of your series chapter. You're going to be thinking like that. We haven't even had a number yet. right? It gets very abstract. So letter D, we also have f of x diverging, right? And now we have g writing under it. It's inconclusive. All right, so that's done. The next page. We're going to kill off a big chunk of this worksheet. Letter number 3, you can cross off completely. All right, number 4, I'm going to discuss part A. We'll do part B. You can cross C and D off. All right, so we're just cleaning up worksheet 10 a bit here. I like the rest of it. All right, and I kind of like some of the stuff I'm discussing right now, but 5 on is really the meat of your assignment. So while I'm talking about it, number 5, circle it. I want you to show the full limit process for that one. So write full process. Flip the page. Number 8, I also want you doing full limit process. Even though they're multiple choice, I want to make sure you know how to write that out. All right, we're going to go talk about number 4. So on number 4, it says determine if it diverges or converges by finding a function to compare it to. And we're going to have, like I said, something called a comparison test when we get to series. It says justify by showing the inequality and discussing, here, I'll tell you what all that means. So here's what you got, and thanks for listening, because this isn't stuff you have to do, but it's kind of good when we get to series. You'll be like, oh, I kind of remember her talking about a fence for divergence and being under a convergent converges. This guy right here isn't one we did yesterday, but it's really close to one of these guys, and we talked about what these guys do, right? We said if P is less than or equal to 1, what does it do? Diverged. If P was greater than 1, it converged, and we also proved what it converged to. This isn't directly one of these, but it's super close. If I take off this insignificant -1 that means nothing as I go to infinity, I'm really looking at something very close to x to the 5th over x to the 6th, which is very close to what? 1 over x. So when we're doing our series, you're going to go, you know what, I'm going to try comparing this to 1 over x because I know it does what? Diverges. And if mine's over it, I've got a conclusive, easy conclusion. I'm over a divergent, I will what? Diverge. If I get under it, bad test. All right? So let's go take a look at it. I want to take and make sure that mine, which is this guy, rides over one that I know diverges. So really what I have to do is convince myself that mine is bigger than the divergent one. By the way, if they didn't teach you this in other levels of math, when you're comparing fractions and you want to quickly just know which one's bigger without a calculator or getting a common denominator, if you start in the top left and just compare products, 55 is less than 63, it means that fraction's less. So that's a really quick way to do comparisons of fractions without having to go decimal or common denominator. All right? I'll do another one. For example, 2/3, and maybe I'll pick something that's really close, 22/33. Those are equal. Look, 66 equals 66, right? But if I go like this, then I've got 66 on this side, which is bigger than 63, so I know that's bigger. You compare, it's called comparing the means with the extremes. So on this one, you always start in the top left. You can definitively tell me this one's greater than this one if that product, which is x to the 6th, is 100% bigger than x to the 6th minus 1. Are you convinced that that's totally true? Yeah, right? It's got to be bigger, correct? So that would mean that, and so this is enough, by the way, when we get to series, you just need to show that you're riding above a divergent. All you need to do is compare the means with the extremes, and if this one is definitively bigger than it minus 1, you can tell me the fraction's bigger. So you have now just shown me that you're riding above a divergent. So what do you think the answer is to 4A? Diverges. And I won't ask you these on the test, but I like the thought process, and you guys are actually good at it. Let's go look at B, and you can cross off C and D, just because it's coming at you in a whole nother chapter, but I like it. For B, it's very close to one I know, even though it's very messy. On the top, I have an x to the 3rd plus stuff I don't care about, right? On the bottom, I have an x to the 4th plus stuff I don't care about squared. So really, if I just look at powers, x to the 3rd is battling out x to the what on the bottom? 8th. That's super close. to one that I know, right? What one? 1 over x to the fifth, right? And what do I know about 1 over x to the fifth? It converges. Yeah, as long as I'm going up to infinity, and I'll talk about, I made a mistake on the key because I wasn't watching the bound, so we'll talk about that. We'll just kill off a bunch of this worksheet right now. Are you all right with that? All right. So if I can definitively show that the one I'm trying to work with, this guy, I'm going to write it like this, x to the fourth plus 4x plus 1 times itself, just so you can see it. I want to make sure that the one I'm working with, do I want it to ride above or below that guy so that I can make a conclusion? Below. Do you get why? Because I know this guy here converges, and so if it's converging and I'm below it, I'm going to get squeezed down fast enough as well. So I just need to convince myself and my teacher that this is, I'll put a question mark over it. What did I say to compare? Crisscross, compare, and I always start in the top left. I've got to convince myself numerically that x to the eighth plus x to the fifth has to be less than this way. Well, watch when I start to write it out. I'd have x to the eighth when I do these firsts. Then I'd have a 4x to the fifth, plus I don't even care because it's definitely all positive and I'm already over it. Does that make sense? So what could I conclude about mine? I just concluded that it's going to ride under a convergent. So what will it do? There. Okay, that's a common thought process that we're going to have in series, which again, some people do next. Like you'd be starting it next week, so what I just did would have been really valuable for you. But we're waiting till it's going to be February-ish to do series. So I'm going to have to talk about that again anyway, but maybe Adam will be like, I kind of remember her talking. So we're going to go in the notes and we're going to do some that I screenshot out of. I can't remember. They're either out of our book or they're out of the Stewart book. The Stewart book is the one the U of M uses, and I only have a copy because my son went to the U of M. So I sometimes copy stuff out of that book. He went to U of M Morris, but they use the same texts. Anywho, I think these are you examples. One of them is really hard, but I think some of you will understand it. This one is definitely doable, and you will be asked to do ones like it. So we're going to start with this guy. This is example 5. The book I took it from, it was there 6. I'm just not doing all. There were 11 examples. I'm like, oh, if I did 11, I'd kill them, right? So I picked good ones. Anyway, this guy right here, definitely improper. How do you notice that? The 4. So we're going to pass to the limit because it's not multiple choice. So we're going to take the limit. I've been surprised with how sometimes this yesterday and today messes with people's heads. I don't think it has as much as usual, which I like actually. Makes it easier on me. All right. So we're going to take the limit as b approaches 4. From what direction? The left, because I'm going from 0 up to 4. Now, somebody last hour, I think, asked me, does that matter, like, for grading on an FRQ? And I couldn't answer it, because I don't know. All they do is they publish, they say, it's a point for a student uses limit process. So I don't know if just putting a 4 here is enough to bump you out of that point. I'm going to assume it is. So I want you to come in from the correct direction. Because you remember from AB, when you don't have this minus on here, which direction are you approaching from? Both, and we're not doing that. We're only coming in from the left. So let's go do this guy. I'm going to pull the constant out front because I can and I like to, but you don't have to. And then I'll have 1 over the square root of 4 minus x dx. This guy right here, sorry, I forgot to go from 0 to b. This guy right here needs to get done as normal, but I'm also going to give you a couple little suggestions. First of all, I would avoid linkage at all costs. Here's what I mean. If you're thinking u sub and you have to write it down, write it over here, and u would be 4 minus x, right? Your du would be negative dx, so I'm just going to fraction correction that right now. And in my head, I'm thinking I'm integrating, right, from 1 over root u, and I'd have the negative du. Tell me what's technically wrong once I put those limits back on. Right. These are limits right here for x. If I want to have it technically correct, they should be limits for u, but because it's off-end scratch work and I don't have any equals, I don't think you would be docked for it, but I'm going to suggest you just don't even put any on there when you're doing your scratch work. Just go over there, figure it out, and then do what you said, back substitute, and then go back into the red workflow, because then I'm 100% sure you'll get all the points. Do you see what I'm doing, Millis? I don't know where points are allotted. I'm almost positive you're going to have an improper integral. So I want to make sure that you don't lose points because of how I've taught you to do it. So we're going to avoid linkage. We're not going to put any equals in my red. And we're also going to do all our u sub over here. We're not going to change the limits. We're just going to leave them off. And then we'll go integrate this. This is u to the negative 1/2. So when I integrate it, I get u to the 1/2 times 2. It would be negative, right? And then and no equals over here, and it's totally clear to an AP reader that you are outside of your work. So I'm going to do what Adam said. I'm going to go right back and back sub that in. Are you good with how I want you to show it? So when it comes back over here into the part that's going to get graded, I'm going to say this is 6, limit, b approaches 4 from the left. My antiderivative is over here, so I'm allowed to just go root 4 minus x. I'll put the negative 2 out front or leave it in. That's up to you, correct? And I'm going to go from 0 up to b. That I know. By the way, equals here, I haven't made linkage. These are completely true statements, so that's legal. But if you threw some of this in over here, you would get some linkage stuff going on. So we're going to keep that off to the side. If you do that elementary u sub in your head, there's never a point for that. It'll say correct antiderivative, which we've got right there. All right, makes sense, Nordy? All right, so let's go do what it says. We're going to do the negative 12, and we'll do limit b approaching 4 from the left for sure, and we'll have the square root of 4 minus b minus square root of 4 minus 0. Next step, and I'll tell you, you're my second class of this, so you guys get a little bit more thorough, because they ask me questions and I tell you what they ask, so I think it helps being the second hour. But I said this goes to 0, and somebody said, well, how do you know that for sure? And I said, you have to go back to the very first day that we covered limits, which was way back in September of last year. What's the number one rule for taking a limit? You plug it in. Whether it's left, right, or from both sides, you plug it in. And if you don't get 0 over 0 or a number over 0, that's your answer. Do you remember that? Right? So when I plug in a 4, right? Or you can picture 3.999999999, but then this is going to be 0.0000001, and when I root, it's going to approach 0, right? So that is for sure going to 0. But the next one I do, we end up with this when we plug it in. Do you remember? I have to go back. You guys have to remember so much. You have to remember all of AB and then all this weird stuff. It's a lot, right? Do you remember what your answer is when this falls out for direct substitution? What does it mean? You'd need to creep to figure out if your answer is what? Positive or, yeah, excellent, TJ. Positive or negative infinity. Perfect, because that's going to happen next. And then that's one of the inconclusive ones. But a number, that's your answer. So, and I was glad they asked it because I think other people were probably thinking it. So this is negative 12 times 0, right? Minus the square root of 4 is 2. My answer is 24. I had last hour run it through their calculators. We had a variety of answers, but what we kind of realized is when the issue's at the boundary, not on the way, the calculators were trying to do it. So, and one of them's popped up 23.99898, like it tried and almost got to 24. One of the calculators actually went to 24. I think it was the really good Inspires. And then someone else just got the worm. It just kept spinning. But the calculators actually can handle this. You just won't have one. So that's, if you're like, well, I'll just use my calculator. You won't have one. And the calculator wigs out in scenario number 2. This one, if you ran it through your calculators, because the issue's where? In the middle, the calculators don't. And we did that in here yesterday, I think, where we ran it through some different calculators, and they were kind of all over the board, but they all said weird stuff. Didn't one of you have it say warning with a yellow? Yeah, so, I mean, that your calculator struggles because it's not trying to creep up at the end. It's trying to hop the issue in the middle. But how do we write this one out? If you watch the video notes, when the issue's in the middle, you need to make 2 integrals. And you have to be careful how you write it. So we'll have B approach my issue. But when I'm going from 0 up to 2, and I kind of am writing it, that's really not notation, that little arrow, but what am I approaching 1 from? The left. And I do think that might matter. but I don't, and I should post that question to my Facebook group because there are BC readers on there. They would know. I do not know. I would never be a reader for BC. Do you want to know why? Series and polar are a beast to grade, and I would not want to grade them for 8 hours a day for 8 days in a row. I think I'd end up in the loony bin. Like, they're so bad to grade. I should bring up a number 6 so you can see like what the scoring looks like. I'd be like, oh my God. Anyway, AB I can read in my sleep. I'd actually have to focus for 8 hours a day, 8 days. That's how many days we're there doing the reading is 8. Ugh. Sometimes the polar's not bad, but this series one is always awful. Anyway, let's go. Come on, let's go. We're going to go from 0 up to 1, no, to B, and let's write that so we can integrate it. Awesome, children, like that, correct? Then I have to split it, because basically I'm mathematically here, by splitting into 2, I'm kind of dealing with getting over the asymptote. So that's kind of the plus sign. But I need a new limit, and I can't choose B. So last hour they said C, and I said C's already Carl, so we said A. All right, so we're going to take A. It's also going to approach 1, but from which direction? Yes, from the right, and then you're going to integrate from A to 2. One way to check if you have it right is make sure it goes bottom, and then the very top is your top. So if you're wondering if you have it structured right, and this is the same integrand, so that's not going to be an issue. I wouldn't bother doing any kind of U sub outside of your workflow because it's easy. I mean, this technically is U sub, but du is dx. So we can just integrate that with our power rule. So we're going to get x minus 1 to what power? Negative 1/3. So I'm going to put the cubed root of x minus 1 on the bottom of a fraction, and then divided by negative 1/3 times negative 3. So I'm going slow on these because there's a lot of detail. This is actually a hard section, I think, but you guys are tackling it well. So that's my first one. My second one I don't need to think about because it's the same integrand. I'm just doing a little different approach. So on that, I'm just going to throw our thing on there. Boom. Any questions so far? You guys good? Savannah, you good? And I forgot my dx. What do I do? Oh. Boom. 0b. Boom. A2. All right. Next step. Got to plug this stuff in. I purposely am not putting equals because I don't want to set myself up for linkage. I don't have any right now, but that's kind of one of the tricks of the trade that they say if kids don't have equals, you can't dock them. They're not. So I'm going to leave them off. So let's do limit. You can tell I wrote limit a zillion times today. And we'll do negative 3 over cubed root b minus 1, fundamental theorem of calculus, minus negative 3, so watch your signs, they actually mean everything in this problem, over the cubed root of, it's going to be what, a negative 1? No mistakes yet, right? I think I'm good. Then plus, limit. I'm going to only talk about what happens over here because this one gets done similarly. So I'm just going to talk about the left guy. This one right here. Here we go. Can you just plug a 1 in? Definitely. But I got one of the things I cannot have. I can't have negative 3 over 0. So I do know one of the answers, right? It's going to be what? Positive infinity or negative. Now, if there's a point for which one, you want to earn the point. So how do we decide from Calc A, B, like the second week of school? How did I tell you to decide which one it is? Sign analysis with being a creeper. Just in your head, come up from the left and decide if this function's going down or up. You can't use your graphing calculator to go get a visual of this because you won't have it. So you actually have to physically creep in on the graph in your brain. So this inside is going to be negative. The cubed root of a negative is negative, and there's a negative on the top. So this is for sure going to what? That's positive infinity. Excellent. The next one over here, I've got cubed root of a negative 1, which is negative, and then a negative, and then another negative. So all that gives you is this. That's the first part. The second part's going to be really similar. I actually get another positive infinity, and then I think I might get a plus 3, but it doesn't really matter. There's going to be 2 positive infinities. So where do you think this guy's going? Infinity. Yeah, it diverges. So you can go ahead and write diverges or infinity or whatever. But this would be one where you would choose diverges if it was multiple choice. All right, next one up. This one is the kicker. Nod and smile if you don't understand this one because it's got a lot of great math in it. Again, I took it from one of the college books. This is not Calc BC. This is Calc 2 in college, this next one. It's a very difficult question. All right? If you don't understand it, it's okay for you, but I actually think if you're moving on to Calc 3, stuff like this you should understand. All right? That's why I cover it. It'd be nice to know what a hypocycloid looks like, so I'm going to show you. If you ran it through your Desmos, you'd have to run it through because it's not a function. Hypocycloid looks like that. And it says of 4 cusps. So whatever college book I chose doesn't, it calls them cusps. So that's interesting. 1, 1, -1. College Board actually doesn't like the word cusp. They just have to give credit for it because a lot of texts use it. Anyway, here we go. First up, do you remember the formula for arc length? Because it's something that needs to be memorized in here, which is why I purposely chose this one. I'm like, I kind of bring it back in the brain. There's an integral. Let's see if we can piece it together. Get it in your brain, though, because do you remember what's in the integral? There's a square root. There's a 1 plus. Yeah, there you go. Good. F prime squared, we'll call it dy dx squared, and then dx. That gives me the arc length. Here's the problem. You might think, well, I'm just going to go from -1 to 1 and then double it. But because there's a derivative, you can't do that. Because there's a derivative in the expression, I can't do the derivative from -1 to 1. Why not? The cusp, you can't hop it. So you're going to just outsmart the problem. Instead of going from -1 to 1 and doubling it, what am I going to do? 0 to 1 and multiply by 4. Exactly. So we're going to outsmart it a little bit. So ours is going to look like this. We're going to do 4 times. We're going to integrate from 0 to 1. We're going to do the 1 plus. We're going to find a derivative and square it. Do you remember when we did these? Because it was your first test in here. It was a while ago. But if you didn't have a calculator, what did we say had to happen with this? I guess you call it a radicand. But what did it have to be in order for you to be able to do it by hand? A perfect square. So last hour is the first time I had done this since last year, and I was like, I hope this is working out right. And then when I popped out from under the root, I'm like, yep, we're on the right track. Because the odds of you making a mistake and getting a perfect square under here are pretty much 0. So we got one. We had to work for it, though. So let's go over here and write down what we need. We need to find the derivative. So here's my original function. I think I'm going to leave this up for AB because they're doing something right now and they have a test on it Friday and one on their worksheet. I think it even was this one. How do I find the derivative? Implicit. Yeah, I could actually explicitly solve it for y, but that's almost always messier when it's set up for implicit so nicely. So remember that process because this is a good problem. You had to remember arc length. Boom. You're going to have to remember implicit, boom. And then we have to do some manipulation. And this is great. Would I ever ask it on a test? No, but I like it a lot. Are you ready? Oh, Molly. Just looking at you right now, I have to stop and talk just to Molly right now. I had them all register in AP Classroom last week on the day you were absent. I had them click their undecided for the test to either yes or no, and you're still in there as undecided. So the due date's November 8th. So we just did it as a class and you were gone. So remember to do that. I just looked out at you and I'm like, oh, Molly. All right, anyway, back to here. I need to take the derivative of this guy. All right. Let's go do that. This is actually chain rule. This would be 2/3 x to the -1/3 times the derivative of the guts, and dx is 1. But on the other one, good implicit review, it'd be 2/3 y to the -1/3 times the derivative of the guts, and dy dx is y prime, or call it dy dx. I like the y prime, right? So both of them are chain rule, by the way. That's something I've been stressing more this year in AB. I'm like, you are really using the chain rule on this guy. It's just the guts is x and dx is 1, right? I don't think I explained it that way with you guys last year. I think some of you were just tacking on y primes and didn't realize why they were there. So it kind of adds a little better. I think I taught it better this year. I said this is bring the 3 out front, knock it down, and then the derivative of the guts. That's why it's gone with the x term. Did that? I saw some of you just go, oh, yeah, I get better every year too. Right? Anyway, where was I? We're trying to figure out what y prime is. We have plenty of time. So I'd divide everything by 2/3 and just get that out of there. And then I would subtract the x to the negative 1/3, right? So it'd be negative x to the negative 1/3 over here. Oh, and I forgot I didn't leave enough room for my y prime, and it's what I'm trying to solve for. What do I do right now? Divide. Now, this is where actually somebody in my second hour AB asked me to do one like this today. And I said, well, what do you do next? And they said divide. And I said, by what? And they said, by y to the 1/3. And I'm like, no, you're dividing by what's in the way. And then that answer wasn't there. They were doing a multiple choice. Why weren't they seeing this answer? Yeah, they swapped them on the multiple choice problem they were doing. So it actually was y to the 1/3 over x to the 1/3. Now that's my dy dx. This is good math. It's a lot of it. Sorry, Nordstrom, you're tired today, but is it clicking? Awesome. All right, what do I need to do with my dy dx? Square it. The negative will go. So let's go up here. I'm going to have y to the 2/3 over x to the 2/3, correct? And the negative's gone. This right here has another issue. So again, first of all, had to remember arc length. So again, I took this from a college text. I'm not purposely making stuff super hard for you. I'm just trying to make sure you don't only know BC. So first of all, had to remember arc length. Next up, we had to remember how to do implicit. You guys are fine with it. Next up, you have to recognize that this has an issue and we need to fix it. It's not a perfect square. That's coming. It has an issue before. Yeah, you can't mix variables. Remember, if we're in terms of x, it's all x. If we go u sub, we're all u, including the limits. This is all x except that guy. So how do you tackle that? There's two options. Yeah, they said that last hour. Someone said, well, why don't you replace y to the 2/3 with what? That worked. We had a heart. We broke it apart. Things disappeared. It was nice. But actually, a little quicker way would be to do this. If you just crisscross applesauce and get a single fraction, which, by the way, I always recommend when you're doing any sort of analytics, don't have sums and differences of fractions. Usually, if you clean them up, nice things happen. Tell me the nice thing that just happened on my numerator. I did. Look at my numerator and look at my work over to the right. Someone's going to say it. There it is. Someone always sees it. Yeah, my top is this, and this is the original problem. It's 1. So, yeah, way. Cool, right? So I end up getting this. And on the top, is x to the 2/3 a perfect square? It's x to the 1/3. Yeah, so it's x to the 2/3 to the 1/2. But this is where last hour is like, yep, I'm doing it right because that just popped out from under the root. Because sometimes even when I'm doing it for the first time in a year, I'm like, where do I go next? So I was kind of doing it on the fly last hour. Guess what, Adam? I was successful. Sometimes, though, I do it on the fly. I'm like, uh-oh. This did not go. I should stand up here and hold paper, but I don't feel like it. I just do it from my brain. All right, so here's the next issue. Who notices it? This is a what? Ah, yeah. This has to pass to a limit. So we have to do the limit. As b approaches 0 from what? Now, you might get the right answer ignoring that. But I'm just saying, if you actually have to show it correctly, I cannot use 0 down there. There's an asymptote. Now, do you guys get which direction I'm approaching? I will be to the right of it. Oh, so you guys are so good. I'm digging this class right now. All right. Next up, I'm going to be, what am I doing? Integrating x to the negative 1/3 dx from b up to 1. I'm starting to lose my focus. It's a very easy antiderivative. This 4 is going to hang out front. Last hour we got this far. I'm like, what am I trying to prove again? I forgot, and I lost the stem of the problem. They said, we're proving that the arc length is 6. Yeah, I'm like, okay, we're going to get there. So this would be limit b approaching 0 from the right. Don't show anybody this problem in AB. This would be x to the 2/3, right? Times 3/2. I like to pull that out front, if you don't mind. Boom. I'm going from b up to 1, which I really like, because what's sitting out front of the limit? 6. And what is this? 1 to the 2/3 minus b to the 2/3, and b is approaching 0. So what's that going to give me? 1. Yeah, I'm not going to write that out. It's going to be 12/2 times 1 minus 0. So I did just show it, so that's actually nice. Now a way easier one, but I chose it. Again, everything I choose is for a reason. I wanted this one for you to remember the arc length formula. Honestly, that's why I picked it. Because I put one on your test for Tuesday. I do give you a multiple choice for arc length. I filter them so that we're not trying to remember everything in May. Some of it should still be in there. Anyway, this one I chose for a reason, because you're taking that graph we did yesterday, part of the volcano graph. We're going from 1 out to infinity this time, but I'm not doing the area. Read the question carefully. What am I going to do with this stuff? I'm going to revolve it. Picture what it's going to make, by the way. It's going to have like this circular thing. It's going to look like a horn that sort of never ends. Yeah, what'd you say? Oh, I thought you said Gabriel's horn. I'm like, that's actually what it's called sometimes in text, Gabriel's horn. But you didn't say that. I have these earmuffs on. I can't hear everything very well. All right. So here's a couple issues with a question like this. I always get kids that go like this. Oh, I'm going from 1 to infinity of 1 over x squared dx. Nuh-uh. By the way, that red stuff, what will that find for you? Not the answer to this question, the area. And we already know that answer from yesterday. Do you remember what that is? 1. Yeah, that's not what we're doing. We're revolving it. We're going to add up. We're adding up a bunch of disks. They're cylinders. What should be in front of here? Pi. What should be happening with this? Awesome. Those are the two most missed things with one like this. Now, to wrap it all up for the day here, this becomes 1 over x to the 4th dx. The whole reason I spent half an hour yesterday doing some pre-notes is so that you, if you remember it and they settled with you, this is common knowledge if you remember what we said it was. If not, you got to go do it by hand. Yeah, it's going to be pi thirds, and I'll allow you to go right to here, because we proved this is 1/3. But let's suppose that Sammy's like, I forgot if it's 1 over p plus 1 or p minus 1 or q to the 4th power, and he's like, plus I was sleeping yesterday. You should know how to integrate x to the negative 4th anyway, and you should be able to figure it out. But it always is that. By the way, one thing I did on the key, we're done. That's done. But I want to show you one on the key I did wrong because I wasn't paying attention. Go to number, well, first of all, number 5 you have to do longhand. Number 6, that can be done with yesterday's stuff if you remember. It doesn't say to do it by hand. It's 1 over x to the p with p greater than 1. You should know what you can do for a shortcut. I unfortunately did the shortcut to number 7. I was like, oh, x to the p. P is less than 1. It diverges. I circled E on the key. It's not. I totally ignored the bounds. I was just kind of in the zone making the key and going like, oh, 6 is easy. Oh, 7's easy. And then somebody last hour was doing 7. I walked around and they got a different, I'm like, I said, that diverges because of yet. I'm like, oh, no, it doesn't. I kind of stopped myself right in the middle. Anyway, why don't you go do 7? Just to make sure you have to do 7 the long way. But you can cut out some of because it's multiple choice, if you want to cut out some of the formal notation, you can. But again, we can't say it diverges because p is less than 1, because that only works when we're going to infinity. We did the proof yesterday for a to infinity, not to 1. Yeah, I would even show your notes. I mean, I'd show a limit, x is approaching 0 from the right. I would maybe do that one the long way. This is due Friday, by the way, with what I give you tomorrow. We're done, though, for notes. This chapter's over and done. Oh, I forgot I still have my headset on. Hi, guys, if you're listening to this. I'm going to go turn it off.